Hello guys, so this video of mine is uh, uploaded after a very long time. I first uploaded my first video. So this video is going to deal with diols actually. So we have many different processes of converting an alkene to a diol. So basically this is a vicinal diol, and in this video we will be studying about how to convert this to this. In the next video I'll be showing about how to convert into geminal diols and what are the stability things of geminal diols and stuffs. So first method, it's a very known method, that is Bayer's reagent. So what you need is an alkene, then KMnO4, that is alkaline, H2O provided, then it will be converted to a diol. We have a diol out here. So actually the solution containing this diol will be pinkish in color. It's actually also a confirmatory test of having an alkene in the compound. Second is OSO4, osmium tetroxide. Actually it's also kind of very known method. So this also we're doing OSO4 2. So this will be diol out here, Vicinal diol. So the next reagents are a kind of bit out of the order. So actually you won't be needing these kind of things in exams like JEE or NEET, but for the sake of knowledge I'll be telling about this. So one is known as Woodward reaction. Woodward reaction. So what do we have? We have 4 different kind of alkyl groups attached like this. Then we have AGOAC. I want you to note this so we can later study them. AGOAC, then I2 iodine, then water H2O and AC2O. Sorry, ACO2. So then NaOH. That's it. This is the reagent. I know you can remember this big reagent kind of thing, but at least if this comes in the exam you can know that this kind of Woodward reaction. So what will happen? A diol is formed. So this is a syn addition. As you can see that both the OH groups are attached in the same order, that is the same direction, that is upward. And fourth we have Prevost reaction. It's also a very out of order reaction and you won't be needing it in exams like JEE or NEET. But as I'm again saying, for the sake of your education, for the sake of knowledge, yes, there's nothing to bound you. So what we have, 4 different kind of alkyl groups. Actually I'm showing you the 4 kind of different alkyl groups so you can later just do these things with different kind of groups and hydrogen also. So what we have out here is PH CO2 Ag I2 and then NaOH is 2O. pH, we know what's pH, phenyl group, COO2. See, it's actually in combined states, somewhat like this. Benzene, CO minus, Ag plus. And then I2, that's iodine, NaOH, sodium hydroxide, and then water. So what we have a carbon R1, R2, R3, same as we have earlier. Notice that the OH groups are attached in different directions. That means there is a kind of trans addition out here. So it's a very common thing that in this reagent, with this reagent, from converting alkene to a diol, this reagent will make a trans addition out here. And again, in case of Woodward reaction, this reagent will convert the alkene to a sine addition, that is a sine addition vicinal diol. So I'm now showing you a very common method. Actually, it's actually a bit out of order, not a bit out of order, but yes, you can know it. It's common actually. So what we have here, actually I'm going to prepare an epoxide kind of thing from an alkene. So we have an alkene, then you put MCPBA or MMPP. I'm saying we have to use this or this, not this in combined state. This both will be doing the same thing. So this is what a chlorine based compound, and this is what a magnesium based compound. And in this, out of this both, this MMPP is far more stable than MCPBA. So this will be doing what? This will be doing like this. That is, if I draw the structure of it, so it will be something like this. So now if you just do H plus hydrolysis, it will be CH2, OH. Again, if you want to convert an alkene, that is from this to this, you can use another kind of thing, that is peracic acid. The structure is somewhat like this. So this will do this alkene to this epoxide, also forming a byproduct of RCOH. So here again, from this you can convert it to diol by H plus H2. It's actually very easy kind of thing. You can do this very easily. So what have we learned from the beginning? So let's revise it a bit. So as far as the diols, that is vicinal diol, is concerned, so I think I've studied a lot as far as the preparation of diols from alkenes. First of all, you have Bayer's reagent, that is alkaline KMnO4, converting an alkene to diol. Second, we have OSO4 osmium tetroxide, again alkene to diol. Then we have a Woodward reaction, this reagent to diol, vicinal diol. Then we have Prevost reaction, from this via this. It's the reagent, it's actually quite heavy, so you don't have to remember all of it. I mean, you have to remember, but you can't remember. It's actually, your syllabus is quite heavy on you, but if you remember, it's good. If this comes in your exams, you can easily tackle it. So this also converts it to this. Remember, this is trans addition, and the earlier that Woodward reaction was sine addition. So this is like from alkene to epoxide, as you have said, MCPB or MMPP. Then you have peracic acid converting alkene to epoxide, and then from epoxide kind of thing, we can easily hydrolyze it to diol. Thank you guys. So I hope you like my video. Do share it and subscribe to my channel and help us grow. Thank you.